The Kenya National Examination Council. We have the KCSE 2024 question 21 on cycle theorem. Let's see if we can solve it. So we begin with the first part. In the figure below, O is the center of the circle. A, B, C, and D are points on the circumference of the circle. A, O, X, and C are points on a straight line. D is a tangent to the circle at D. Angle BOC equals 48 degrees and angle CAD is 36 degrees. Determine the sizes of the following angles. Angle OBD. So, to find the size of angle OBD, let us introduce this radius OD, as you can see in the diagram. If that is the case, then you agree that the angle here is supposed to be 36 degrees. If that is the case, then we can find the angle that is here, and that should be equal to 36 plus 36 using the exterior angle theorem, which is 72 degrees. So by the exterior angle theorem of a triangle, the angle here is supposed to be 72 degrees. So if that is the case, we can find this whole angle here, which is 72 plus 48, and that will be 120 degrees. So angle OBD, using triangle OBD, angle OBD plus the angle ODB we add it to the whole angle here, which is 120 degrees, should give us 180 degrees. And recall that angle OBD is equal to angle ODB because they are base angles of isosceles triangle OBD. So we are going to get angle OBD plus angle OBD, which is 2 times of angle OBD, to be equal to 180 minus 120, which is 60 degrees. So dividing through by 2, we obtain angle OBD, to be equal to 30 degrees. Now let's look at the II, angle CED. To find angle CED, the angle here, what we can do is that you remember that this angle will be 90 degrees because ED was given as tangent. It's a tangent. And this is 36 degrees. So from triangle AED, this angle plus this angle plus this angle should be equal to 180 degrees. So angle CED plus 90 plus 36 is 126 degrees plus 36 degrees to be equal to 180 degrees. So angle CED will be equal to 180 minus 126 plus 36 will be equal to 162. And that will give us 18 degrees. Now let's proceed to the B part. Calculate the radius of the circle given that AB equals 7.6 centimeters. Correct one decimal place. So we introduce a line like this to get the AB to be 7.8. And this line ON should divide it into two equal parts. So we have 3.8 here and we have 3.8 here. The whole of this angle should be 132. So that when we add it to 48, we get the sum of angles on a straight line to be 180. So the small angle right here should be half of 132, which is 66. So we get a triangle like this. We have 66. We have R, and this is 90 degrees here. And we have this to be 3.8 centimeters. So using this right angle triangle, which is right triangle ONB, we can now determine the radius of the circle. So sine 66 degrees will be equal to opposite side of the triangle, which is 3.8 centimeters, over the hypotenuse, which is equal to the radius of the triangle, the radius of the circle. So the radius will be equal to 3.8 divided by sine 66 degrees, and that will evaluate to 4.1596, or to one decimal place we have 4.2 centimeters. So to calculate the value of XC, we use the ratio given to us. We're given that X divides AC into 3:4. So this tells us that AX over AC will be equal to 3/4. So AX will be equal to 3/4 times 17.755 minus 7.8, and AX will be equal to 7.46625. So we know that AX, which is 7.46625, plus XC, which we don't know, plus EC, which is 7.8, should give us AE, which is 17.755. So XC will be equal to 17.755 minus 15.26625. And this will simplify to 2.48825, which is 2.5 centimeters. to one decimal place.